Tangents and normals to curves, applying calculus to graphs. Let's start with the first example. Find the gradient of the tangent to the curve of x squared plus xy equals y at x equals 3. Now remind you that the derivative is the rate of change, or in other words, the gradient of the tangent to the curve. So to find this gradient, we need to differentiate x squared plus xy equals y. To do that, we're going to have to use implicit differentiation because of the x's and y's mixed. Derivative of both sides. Derivative of x squared, 2x. Derivative of xy, well, product rule. Derivative of x, 1 times y plus x times derivative of y dy by dx equals dy by dx. Collect dy by x dx's on one side, take out a common factor, and solve for dy by dx. Now there's our value of dy by dx. Now to find the gradient of the tangent to the curve, we have x's and y's, so we need to know the y value as well. So what we're now going to do is take the x value of 3 and substitute into the original equation in order to solve for y. There y equals negative 4.5. So now we know that we have the point 3, negative 4.5, and we're now going to substitute that into the derivative. And that simplifies to negative 3/4, so there is the gradient of the tangent to the curve at x equals 3. Find the equation of the tangent or tangents to the curve of x minus 2 all squared plus y plus 3 all squared equals 10 at x equals 1. So we need to find two things. We need to find the gradient and we need to find the y value to have the coordinates of the point. First of all, implicit differentiation, x minus 2 all squared, well, that's going to go by chain rule. Outside function 2 into x minus 2 all squared times derivative of the inside, which is just 1. You don't have to show it, but it's shown here to make it clear. Differentiate y plus 3 all squared by chain rule, so it's 2 times the inside function to the 1 times derivative of the inside function, and of course the derivative of y is dy by dx, derivative of 3 cancels out, equals derivative of 10 is 0. Simplify, and there is the derivative. Now we're going to find the y value. Substitute x equals 1 into the equation, solve, and we get y equal to negative 6 or 0. So therefore we have 2 points, point of contact at 2 places. That's why there is a slash s, just in case there are tangents, and there are tangents in this case. Now we're going to substitute 1 negative 6 into the derivative to get the gradient at 1 negative 6, and we're going to substitute 1 naught in to get the gradient at 1 naught. There are 2 gradients. General form of the equation of the straight line, y minus y1 equals mx minus x1. Substitute the negative 1/3 and the 1/3. So we'll have the negative 1/3 first. We substitute the point 1 negative 6 into the equation with negative 1/3 gradient, and we have the answer. Substitute 1 naught with the gradient of 1/3, and there is the other equation. Now we have to find the equation of the normal to the curve of 3xy squared minus x cubed y plus x plus y plus 29 equals 0 at minus 2, 3. Note that the normal at any point on the curve is perpendicular to the tangent at that point. Some people define it as the line which is perpendicular to the curve. Well, it has to be perpendicular to the tangent if it is a curve. So we're going to find the gradient of the tangent, and the negative inverse will give us the gradient of the normal. Differentiate. Blue, red, mauve, green, purple. Here we are. The blue, product rule. Notice I'm now using y prime just to make it a bit simpler and to save space in this PowerPoint presentation, otherwise I may run off the screen. X cubed y, also product rule. Derivative of x, 1, derivative of y, y prime, derivative of 29, 0, derivative of 0, 0. Simplify, collect the y primes. Common factor of y prime, divide, and there is our derivative. Pretty complex looking devil, that. Now we can substitute in the value of negative 2, 3, the point negative 2, 3 into that, and it gives us negative 8 over 27 at negative 2, 3. Now we're talking about the normal, so that's the tangent, so now we have to find the negative inverse. So we invert, change the sign, and the gradient of the normal is 27 over 8. To find the equation, y minus y1 equals mx minus x1. Simplify, and there is the equation of the normal. Show that the curves x squared minus y squared equals 5 and 4x squared plus 9y squared equals 72 are orthogonal at 3, 2. Orthogonal curves intersect at right angles. They are perpendicular to one another at the point of intersection. So their tangents are perpendicular. So if we're going to show that these points are, or these graphs are orthogonal, we're going to have to show that at their point of intersection, their tangents are perpendicular. Of course, first we need to show that the curves do intersect at 3, 2. Let's solve simultaneously. There we are. So from the first equation we find x squared equal to, we don't have to find x equal to because there's an x squared near the equation. X squared is y squared plus 5. Substitute in for x and the x squared near the equation. Solve for y, solve for x. Notice the plus or minus is grayed out just to remind you that it's there, but we are only interested in the y value of 2 and the x value of 3. This can also be done by substitution, showing that 3, 2 lies on both curves. And that would mean too that they intersect at that point. Now we need to find the gradients at 3, 2. We've shown that they intersect at 3, 2, so we're going to differentiate. They're the two equations, and we're going to use intrinsic differentiation in both cases. Implicit differentiation. Don't know where I get the word intrinsic from. Right. There we are. Derivative of x squared, 2x. Derivative of y squared, we're going to use chain rule. 2y times 2y to the 1 times derivative of y equals 0. This one, we're going to just have 4x, 8x. Then we differentiate 9y squared. Outside function, 9y squared. Inside function, y. So therefore, 18y times dy by dx. And derivative of 72 is 0. Solving for dy by dx in both cases. Now we're going to substitute the point 3, 2 into both. And there we are, 3 over 2, negative 2/3. Well, you'll note that when you multiply these two together, you get negative 1. And when they multiply to give negative 1, that means the tangents are perpendicular, which means the curves are orthogonal.